questions that we want to see, do go over on SharkBite. The ones I'm seeing the most are 1, 2, and 3, so we'll do those 3. We're just going to do this one by hand. There is a way to check it in Desmos, but not a way to actually do it. It would just be using your slider rules, put in everything with different variables, add sliders for everything, change everything to different numbers, decimals, whatever, and then put in your final answer and see if the decimals match. But if we're trying to get W by itself, get rid of 2L by subtracting. And then we can divide everything by W, and we're going to do that separately since this would simplify. Sorry, not by W, but 2. So we'd have P over 2 minus L equals W. Questions on that one? Did you have a question? For number 2, the x and y intercept, there are 2. I'm sorry, there are 1 of each. The x-intercept is at 2, 0. The y-intercept is at 0, 2. And then the line of best fit, we have to put this into Desmos, or if you were using your calculator, that was fine. So I added a table, I put in all the ordered pairs, I see my points, and then in the next line I would type in my y1, the squiggly line, the tilde, mx1 plus b. And it would give you your slope and y-intercept, and you would put that together in your y equals mx plus b. So y equals negative 0.85 x plus 15.9. Would be that final answer. Questions on that? So then we're going to go through the SOL A4A and B. I have some work up there, and then I just start doing everything in Desmos. All of these problems, except for 1, could be done, 2, could be done in Desmos. So if you were at home not knowing what to do, you should have tried to put this into Desmos. I will come back to that. So just write down the answers. Don't worry about the work right now. While you could still solve it by hand, you can also use Desmos and put it in and get the answer. So for any equation that would work, put it in, put the whole thing in, and you will get some answer. And your answer was x equals 0. While we haven't talked about how to find solutions or roots of this, you should know that solutions and roots are the same as x-intercepts. So if you type that into Desmos, you're looking for the x-intercepts. And there are 2 of them. You can write them different ways, like this, in curly brackets as ordered pairs, but negative 4/3 and 2 for number 2. And then there are 2 answers again for number 3, negative 6 and 2/5, or 0.4. And then on the next page, because we're dealing with equations again, you can put these into Desmos. If you put this whole thing in and nothing appears, you have to put each side in individually, and you see that they're parallel lines, so no solution. 5 was 1 solution, x equals 0. 6, again, if you put them in, nothing would appear, but if you put in both sides separately, they would overlap, so infinitely many for 6 and 7. 8 was C. 9 was D. And those are equations you can put directly into Desmos and see where that line is. Was x equals negative 12.5. 11 and 12, for some reason, were repeats of the 2 questions before. So the answers are the same. X equals negative 4/3 and 2, and x equals negative 6 and 2/5. And then on the next page, what was that? So it was 9. D. D was 9. 9 was D. D. 13 was D, 14 was C. Again, those are identifying solutions. So x-intercepts, you put that in, you find the x-intercepts. 15 was plot the solutions. Solutions are x-intercepts. 16 is properties. So this is one you couldn't do in Desmos because you have to know the properties. But from step 1 to step 2, the property would be the subtraction, POE. You can just write that instead of all of those words, but it's property of equality. You don't have to write what's in parentheses. Those are just what those mean. Step 2 to step 3 was additive inverse. Step 3 to step 4 is really just substitution, so don't write subtract, but just substitution. Step 4 to step 5, additive identity. Step 5 to step 6, division, property of equality, or POE. And step 6 to step 7, multiplicative inverse. Finish that. On the next page is the last question from this section. Was C. Again, a property question, so you have to know what your properties are. Okay, so I'm going to show some of these in Desmos. Everything except these last two and the graph one, since the graph was already given, could be done in Desmos. So if I put in an equation, put in both sides, it's going to give me what that solution is. You look for the x value, x equals whatever that is, so in this case 0. But it's asking for solutions or roots. Once you put in that problem, look for the x-intercepts, and then you could write those down, and those will be your answers. If you put in something and don't see anything, put them in separately. You'll see that these two are parallel lines. They would never cross, so no solution. Another solution. Same thing here. If you put them in and nothing appears, put them in separately, and you see that they overlap, so infinitely many. The other ones you could type in to find solutions. So be actively using Desmos when you're practicing this at home, because most of these questions can be solved in Desmos just by typing in the equation. Alright, so in your notes from last class, find this. Did we talk about scientific notation last class? No, so we're good at all. Yes. Anyone else need another one? This will be in this same packet of notes.
I might have
In this packet of notes.
Is that the fun?
Yes.
Okay.
In this packet of notes. Alright, so most of you should have seen scientific notation last year, maybe 7th grade. They are revamping the curriculum and putting it back in high school, so hence this. So if you know how to do it, great. If you have never seen this before in your life, we're going to learn it. Go ahead and write this down first. Some of this was already there, and then I changed some of it, so I'll read it out loud. Scientific notation is a compact way of writing very large or very small numbers in the form a times 10 to the n, where a is between 1 and 10, and n is an integer. And usually your a value is positive.
What's the last part parentheses?
So for example 1, the minimum distance from the Earth to Mars is approximately 284,000 miles. Does anyone know how we would write this in scientific notation?
284
So not cubed, but to the power of 5. So you're thinking about there's a decimal place at the end, and you are moving this decimal place until it's between a number between 1 and 10. And however many places you move the decimal place, that's your exponent. You might see the base 10 as an E instead in the calculator. We'll talk about that when we get into some of the operations. Questions on that? Okay. In example 2, the 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of a day 100,000, 10,000, 100,000, million, 10 million, 100 million, 268. 100 million seconds shorter. Write the number in scientific notation. Anyone know how we would write that one?
2.68 times 10 to the negative 6.
2.68 times 10 to the negative 6. We go 1, 2, 3, 4, 5, 6. And put that decimal place there. So when you start with a really small decimal and you're moving backwards or moving to the right, you have negative exponents. When you're moving to the left, you have positive exponents. The more you move to the left, you're going to add the number of exponents. The more you move to the right, you're going to subtract the number of exponents. Are there any we want to see in number 1 through 12?
We do 2 and 5.
2 and 5.
And 7 and
7 and 11. So these numbers up here are in standard form. We want to convert them back to scientific notation, so we want it in this format. Think about the decimals behind. We're going to move it how many places? 2. So this would be 2.08 times 10 to the second power. 5 is already a decimal, and we want to move it until it's behind the 4. So again, 2 places, but to the right. So this would be 4 or 4.0 times 10 to the negative 2. Then 7 and 11 are already in scientific notation. We have to rewrite it so that it's in standard form, so it'll look like one of these. So for number 7, if we move this decimal back 2 places, that would just be 254. For 11, I'm going to write this over here. For moving the 4 back 4 places, put zeros in all of those places. Questions on any of those? Okay, so now we're going to get into the actual operations piece of it, which you may or may not have done in 7th grade. So you have to make sure the exponents are the same when adding or subtracting. Think about this like combining like terms, but not at the same time. If you want a mnemonic to help you remember, you could use LARS. If you're moving it to the right, the decimal place to the right, sorry, I said that backwards. Anyway, the right you would subtract, the left you would add. So with this, you actually add or subtract the numbers. So like in this one, if you have common coefficients, add 3.4 and 5.2. Tell me what that is.
8.6.
And then because these are the same exponent, you just write times 10 to the second power. That part does not change. You're not adding the exponents because we're not multiplying the bases. But if the exponents were not the same, so like number 2, you have to change one of them to become the same exponent. It does not matter which one. So we can choose to change the first or the second if you want an easy way to remember it. If you have positive exponents, I would go with the bigger one. If you have, make it into the bigger one. If you have negative exponents, make it into the smaller one. So if I were to change this exponent to be 7, I would be going up an exponent or adding. So I'd be moving this to the left, the decimal place to the left. And now that the exponents are the same, then I can do the same thing we did in number 1. So 9.5 plus 0.11 would be 9.61 times 10 to the 7th. Now, if you hadn't done this way and you changed the first part instead of the second part, what's going to happen is you'll have something like 96.1 times 10 to the 6th. But this isn't in actual scientific notation because the decimal place isn't between 1 and 10. So you would have to move it to the left and add 1 also. But it doesn't matter which one you choose. You can also use your calculator. It's going to give it to you in standard form. You could go back and convert it, or if you want to see it in scientific notation, you can go into mode, change normal to size, scientific, and then do it again. The E is the same thing as base 10. It's similar, it's not necessarily the same, but you could do that also. Questions there? Did we want to see 3 or 4 before we go on to subtracting? Which one? 3. Okay. So we'll do 3 and then go on to subtracting. So we have 2 different exponents again. If we change this exponent to become the smaller one, we don't have to do double the work. So by changing this to -4, we're going up 1. So we're adding 1. So we would move this to the left. And then we could add the 2 numbers. So 7.24 plus 0.318 is
7.558
times 10 to the -4. Go on to the back so we can do some subtracting. So let's do 8 instead of 7, but same process. If the exponents are the same, just subtract the 2 numbers, bring down the 10 to the whatever. So go ahead and subtract 7.59 and 2.32. And then I would just bring down times 10 to the -2. The exponents are the same, so I don't have anything to change there. And then we could do another one where it's different. So I'll let you guys choose 9 through 12. Okay. So if we're doing number 12, and I'll let you guys choose also, do we want to change the first or the second? Okay. So if we were to change the second to become the first, we're adding 1, so moving the decimal place to the left 1. So 0.27 instead. Now we have common exponents. Then we can subtract the 5.3 and the 0.27 to get 5.03 times 10 to the -1. With your subtracting, if you change one of them but get a negative number, something is off there, so be careful. Other questions in that section we want to see before we go on to multiplying and dividing? I did mean to mention at the beginning, our exponent rules tells us to change a negative exponent. Scientific notation can have negative exponents. Do not change those. Leave those as is. Alright, for multiplying and dividing, actually multiply and divide the numbers, but then we also have to take into account our exponent rules, our product rule, our quotient rule. So if we multiply like bases, add the exponents. If we divide the like bases, subtract the exponents. And then use your mnemonic if need be. So in number 1, multiply 2.8 and 1.9. What would that give us? Okay. 5.32. We are multiplying like bases, so we're doing what with the exponents? Okay. So then our new exponent would be 11, 7 plus 4. Multiplying the like bases, but adding the exponents. And that's it. That would be your answer. Again, you can double check these in your calculator. In scientific notation, this number is way too big, so even if you were in normal, it would still give it to you in scientific notation because there's so many zeros. Questions on that? You might get something like, I'm trying to remember which number it was. Multiply 3.4 and 8.5. Tell me what you get. For number 3. Okay, so it wasn't on. And then our new decimal would be 4. This is not in scientific notation because the decimal place isn't between 1 and 10, so you have to change this, move this to the left, add 1 to the exponent. So if you get something not in actual scientific notation, make sure you change it. But if it's already in, then you're good. Questions on that one or other questions in the multiplying section? 2, 4, 5, 6. Okay. The division works basically the same way. So in number 7, divide the actual numbers. 3.72 over 1.2. To get and then if we are dividing the like bases, what are we doing with the exponents? Subtracting. So our new exponent would be 3. We'll do one where we have to change the decimal place, and then any of you guys want to see do go over. So number 10. Go ahead and divide 2.1 and 2.8. What would we get there? And then if we're subtracting our exponents, our new exponent would be 4. But our decimal place is not between a number between 1 and 10, so we'd have to move this to the right one. Which means we're going to go down in the exponent, subtract 2 times 10 to the third. Do we have any questions on how the multiplying or dividing works? Any others we want to see you go over?
How did you divide the exponent?
Say that one more time.
How did you divide the exponent?
You subtract the exponents.
Is 12 or the same as
Yes, it's just in a different format. So it would be 2 divided by 3.2, 6 minus negative 7.
Yeah, because you said
Yes.
So good.
Most of it's practice.
I quit.
Okay, so this is the last thing that we have to talk about before your quiz, before your test. Polynomial operations. Oh, one last thing about scientific notation. That's going to be mixed in with your exponent rules, so you have to know the difference between just simplifying your exponents using your rules and using your scientific notation. Second. For your polynomial operations, we'll start on just the left side first. Your adding and subtracting is really just combining like terms, where your exponents are not being changed because we're not multiplying, dividing, or raising powers to another powers. So in number 1, if you want to take it out of the parentheses, you can, you don't have to, but we're just adding like terms. You don't have to do this. If it helps you see the like terms, do that. So then 6x squared plus 2x squared would give us 8x squared. Negative 2x plus 7x plus 5x. 3 plus negative 7. Negative 1. That's it. So just combining like terms, something we did at the beginning of the year. Questions on that? Now, the subtracting is basically the same, but there's a little bit of a difference. You can do it the same way. We'll do that second. But you have to remember, be careful with your negatives. What you could do to avoid that is distribute the negative. And then just rewrite everything. So if we distributed the negative, rewrote everything, and then combined like terms. (3x squared minus 4x squared would give us negative 1x squared, 5x plus 7x plus 12x, and then negative 6 plus 9. Now, if you were just doing it from the parentheses, again, it can be done, just be careful. 3x squared minus 4x squared, 5x minus a negative, and negative 6 minus a negative. So be careful with your negatives. Questions on that one? Looking at 3, 4, or 5, are there any of those that we want to see you go over, have questions about? Okay, so let's start with 6 then. If we had just a regular number outside of parentheses, what would we do with that number? Distribute, multiply it to everything inside, so what would that become? We're going to do the same thing with all of these, but because we are multiplying things with exponents, we are now adding the exponents together. So we're going to distribute this entire term to each term inside. Negative 4x squared times x squared would give us to the power of 4, because we're adding the exponents. Negative 4x squared times negative 5x, positive 20 x to the third, because there's an invisible exponent of 1. And then negative 4x squared times negative 3 to the second power. Questions on that?
Is there not one exponent and 3 as well?
This one actually has an exponent of 0. Anything to the 0 is. Was anything to the 0 power? So you don't actually see it. So no, it doesn't have an it does have an exponent of 1. Also, yes. But the variable doesn't have an exponent of 1. So that's not what we're adding together. Other questions on that one? Okay. Let's do another, and then we'll see if you guys have any other questions. Number 8, distribute the 2x to the third to both terms. What would that give us?
14x to the 4.
Minus
6x to the 4.
6x to the third. Do we want to see 9 or 10? So if we're multiplying negative 3x to everything here, what would this give us? Negative 18x to the 4th. Then to the third, and then what's the last term? Minus 3x. Notice that in all of these we are not doing anything else. Once it's here, it's done. We're not combining the exponents, changing them, nothing else. That is just your answer. If, for some reason, the inside was not in standard form, highest exponent to lowest, make sure it's in standard form. Questions about how to add or subtract polynomials or multiply monomials to others? Okay. So there's one last thing we have to talk about with this, but we're going to do that next class. So we'll do that and then you'll have time to review. But for the remainder of class today, you could be working on any of these things. I didn't tell you what SOL was due next week. So on Monday of next week, SOL A4C through 5B, so everything in between 4C and 5B is due on Monday. So you can be working on that. Again, use Desmos, because most of those you've done, you could do in Desmos. More practice in the notes that I just gave you, or the scientific notation notes. If you didn't complete the 2 delta maths from Friday, you could be working on that. You guys have 2 delta maths due this Friday on scientific notation and polynomial operations. You could be working on that. If you would like additional practice for your exponent rules, I have exponent rule review books that you are welcome to grab. You have plenty to be working on. Work on something. You guys can move around if you would like to.